I will present 3 work we did in Mediterranean. First of all, thanks for inviting me in this sun-dotted distant land. I'm the only Mediterranean. Looking at the list of attenders is impressive. So thanks a lot for inviting me in this audience. So the first work I would like to present you is a nice work that we carried out in Mediterranean for analyzing some fishing vessel. We installed the system I will show you. Actually, this is a consideration on the profitability of fishing. Because of the overfishing, of the crisis, and the increasing fuel price, and fishing vessel not efficient, I think that the possible solution to the profitability is to decrease the cost of fishing. I see a possible margin of improvement because we studied a lot fishing vessels directly on board. And it's time to act because we have a very big crisis, at least in Mediterranean, and only those that are responsive to change will survive. So this is the system that we developed for, unfortunately, there's no possibility to see the title, Jonas, but anyway, this is a prototype that we installed on board at the beginning on 2 pelagic fishing vessels. Actually, it's a very simple conception. We installed 2 flow meter sensors to measure the inlet and outlet flow of fuel. Then there's a recorder on board and a GPS data logger. With these, fishermen can have a look at how they consume, and there's actually, we noted a behavioral effect on fishermen when they look the consumption. I will tell you what happened in the conclusion later. So as I said, we installed 2 systems in 2 semi-pelagic pair trawler. Then we increased the systems. We installed a bottom trawler as well, but that part is not included in this presentation. So they will, the vessels are in this range. And the main difference between the vessels are in the propeller, in beach propeller. One is as a fixed and one is a contrable. I forgot to tell you that this semi-pelagic fishery is a pair trawling. So there are no doors. There is one trawl towed by 2 vessels. And the area is the central and the northern Adriatic Sea. So these are a pair that we measured. The catch are mainly on anchovies and sardine. So this is the fuel consumption meter, and this is a screen with a recordable part installed on board, and this is a GPS recorder. This is the inlet and outlet meter, flow meter installed. More or less the size of the meters. So, the principle is very basic. When there is no flow, there is a phase. The two flow are in phase, and when there is a flow, the mass cause a Coriolis effect. I'm not sure to tell you anything more about this, but the phase of the tube flow is proportional to the flow to the mass passing on the tube. So this is the Ancona Harbor, where my institute is actually located. This is the departure and the coming back of the vessel. And this is a typical one-day trip. So color here are holes. The semi-pelagic fishery, we identified some phases. Searching, pre-shooting of the gear, shooting, trolling, when the vessel accosting and then hauling the troll. We named these with this acronym. Take care, because I will use in the graphs now. So TRA stands for trolling, shooting, hauling, sailing, departing, and sailing back, searching, all together. So these are the results of one pair and the other. We couldn't. The fishermen asked, please do not show our name because of problem with vessel engine. Anyway, this is the SSS stands for sailing, and this part is should be the trolling. And this is in x-axis there is a speed, and this is fuel consumption. So one has around 1.30 liter per hour, and the other more or less the same, a little bit more. There's this variability because when they are ashore, the consumption is less. But look at this curve here, how steep it is. Only 1 knot in the sailing cause a very big amount of consumption. Okay, these are phases. These are one vessel, that's the other. So speed in the sailing, one is at 85 and the other 100. In trolling, one at 130, the other 133. This is less than this, significantly less, because it has a controllable pitch propeller, so it can optimize the pitch during sailing. Okay, this is during the sailing, 9 knots till 11.5. If they reduce of half knot, this is the fuel saving. So from 9 to 9.5, the consumption is increased of 13, and so on. So when the fishermen had a look at this value, they decrease from 11.5 to 11, or 11 to 10.5. They decrease half knot. This is the cost of the system, actually, around 9,000 euro, but it contains everything. Also the system for registering, collecting data. Well, that's the second part of our work on this fuel efficiency issue. This energy audit in fishery is a demanding approach from the Commission. Actually, is a very well determined approach. There's a regulatory references you can read about what we call energy audit. But the objective of the audit is to define the energetic profile of this vessel. In this case, a fishing vessel, but we can have everything. These are the part of the process. We have an inspection before installation, then we install. We used to go at sea during the preliminary part, and then we leave the vessel for data processing, and we evaluate. We actually develop some indicator in this work, and then we compare this indicator to understand which is the most efficient vessel. So these are the instrumentation and the parameter measured. The fuel flow meters for the fuel consumption, torque meter and shaft RPM counter for determine the delivered power, oil flow and pressure meter for the hydraulic power, electric power, gear drag, and then GPS for the position. And troll geometry, we use the CMROD Scanner gear monitoring system. All the instrumentation is linked together and synchronized during the audit. These are the acoustic flow meter we used at the beginning. These are portable. The error of this system are very bad, so we haven't used anymore after the first inspection. And these are the strain gauges for measuring the torque, and then determine the shaft, the delivered power. That's the RPM counter mounted on board. These are the flow meter and pressure for the hydraulic power, and for the electric power we use the simple ammeter close. Then we measure the drag. Okay, these are the profile of the vessel we measured. These are the lower length overall, GRT, and then the power and propeller diameter. We use always acronym for problem of confidentiality of this information. These are the indicator, energy consumption indicator, which is an indicator that is proportional to the energy produced by this vessel. And then is an indicator that is the fuel consumption. This must be seen as an out. This is an in. So the rate of the two is very important, determine the efficiency. These are pretty complicated graph. I try to stay on the most simple issue here. This is the total towing force in the x-axis, and then we have the indicator, the power delivered, fuel consumption, and these are the two indicators for the energy and the fuel consumption indicator. So this must be the most simple one for you, fuel consumption liter per hour on the basis of the towing force. These are PTM, all pelagic, and these are all OTB, all bottom trawler. We have here more or less the same, but against vessel speed. So these are the power, fuel consumption, and the two indicators. I don't want to explain more, but because the most important part is this table here. We have two phases, fishing and sailing. This is the out, this is the in. Then we have the ratio of the two. Higher it is, better, more efficient is the vessel. So the rank, this is the first in the fishing. It has the third position in the sailing. And again, these must be the two most efficient vessels we measured. So that's the approach more or less for auditing vessel. These are the conclusions. Our impression is that in Mediterranean fishing vessels are very outdated. So there's space enough for improvement. And as I said at the beginning, energy saving is the only way I see at the moment for improving fishing. Very simple. During navigation, controllable pitch instead of fixed pitch propeller as a very simple indication of having saving. Pitch can be adapted to fishing or sailing very easily. That's a trivial conclusion, but actually there's no way to go at the maximum when you can have just half a knot less and save 12–13% of fuel. The other part, hydraulic and electric user, are not so important, at least for the Mediterranean vessel. I included this third part. I'm not sure that I will show you, because actually I saw that Ulrich will have later more or less the same presentation. Not the same, but actually he will discuss about otterboard. Anyway, we tested this door for improving the design, and we tested this Tiburon semi-pelagic door, and we this vessel speed. This is the fuel consumption. The traditional, sorry, let me see. Traditional against the Tiburon semi-pelagic door. Fuel consumption was less for, of course, for the new door, considering the old style of Mediterranean doors. So these are the parameters we measured: speed, horizontal door spread, horizontal net opening, vertical net opening, and this is fuel consumption. So we achieved a different 18% of saving. I don't want to explain more, because as I said, Ulrich will probably have the same, more or less. Anyway, I would like just to show you this profile, because I think it's very interesting, and will give an answer to Ulrich about our discussion we had yesterday. We wonder why these fishermen, when we show this potential technology for fuel saving, they don't go for using new technology, new gears, or new potential advances for improving their activity. The answer, Ulrich, is that maybe they are not bankrupt enough. That's my conclusion. I think that if they will be more and more inefficient to touch the collapse, they will probably decide to go. But anyway, this is the profile. These are week, steaming, shooting, fishing. These are hour per day. They stop fishing Friday, Saturday, and Sunday in Mediterranean. Well, actually, in Italy. And then this is the total of hour of fishing weekly. This is per year. I'm not an economist. I'm just trying to figure out how much they can save. So this is a profile, working hour per week. This is a trawling hour per year. At the moment, the fuel cost is 0.7 euro per liter. At that time, last year was 0.6. Then the V-door, classic V-door, cost 3,500. Tiburon semi-pelagic is a flying door, whatever, cost more or less the double. This is the extra investment requested for having this. The catch was similar. I didn't speak about the catch, but we also investigated the catch profile. And then, considering this fuel cost per year, we could have a saving of 12,600 per year fuel saving. It means that they will have a payback time of 3 months, around 3 months. I think that conclusion, yeah, it's more or less what I already said. Now, I would like please click on this website. Is a new, well, it's not new. It's the third mandate that we have from the Commission for collecting information on energy issues, energy use, everything. You can find all the document on this website. We have to provide information, go to Congress conferences, meeting like this, collecting information and provide this information to the Commission. They will put all the papers, all the document, green literature in this website. It's very interesting. So please have a look if you are interested in these issues. Thank you very much.
When you compare these two vessels, with the same type of machinery?
Yes.
Exactly the same?
What do you mean, in the door?
With
door?
The engine.
Engine. Can you say again? Because I'm not sure to understand what you mean.
Was it the same type of machine, engine? And also, was it the same? Was the same rev on the propeller?
No. Everything different. So I compare two vessels. One has a fixed pitch propeller and the other a controllable pitch propeller. More or less the engine power was the same, but the brand of the engine is different. And actually the most efficient was also pretty new compared to the other one. So it's a combination of things actually. I just investigated this vessel.
I think that if you come to the conclusion that the fixed propeller or the adjustable propeller is superior to the might not be. I mean, it's also the question of how many revs the propeller has and the size of the propeller, because that is important to the economy of.
Yeah. Actually, I should have included somewhere about this speculation about the pitch propeller. But pelagic, semi-pelagic fishing vessels are almost all the same, around 1,000 horsepower, and same length, same shape. So the most evident parameter was the propeller. Yeah, it's also speculation, but you can understand that having a fixed propeller, the propeller is the same when it's fishing and when it's steaming. So I think that the most is a speculation, I know, because the hull is also important during steaming, but I think that is the most important one in this, at least in this situation, when we have a length overall the same, and fishing is the same, so they are adapted to have the same fishing, is the most evident. But there are many other that can have given this saving anyway. I would like to show you the picture where the vessel are. Look, this is the vessel we investigated, and this is the controllable pitch propeller, and these are the other pair, and we monitored one of the two. I cannot, they are very similar. Is actually one of the two. Must be this one. Anyway. So can be a combination of factors here, but because also this is very old compared to this other. The engine is new, but the vessel is is different. So actually, yeah.
Can we go back to the picture that when you provided the treatment for fisheries for trawling and sailing?
It should be okay. The first piece of work, isn't it?
The final was speculating in there is could you have the most beautiful document the trawling phase?
This is a trawling phase.
Yeah, it looks very similar, doesn't it? It looks a bit higher in EP01, EP01, I mean.
Yeah, there's no significant difference between the two. It's
so in the trawling they were similar, the fixed standards.
Yeah. Yeah. Yeah, because probably they adapt the propeller to the trawling condition.
Okay. Yeah. Yes, actually you are constructing the propeller for the trawling condition. But that's the old vessel, the EP01,
this is the old vessel, yes. And actually also higher consumption for steaming.
Should take into account the full design of an old vessel.
We must take into account, but maybe they didn't in the past. I don't know.
Yeah.
This is quite new, pretty new, and they.
New hulls are better design.
It's your impression, or are you asking?
You have this computer programs where you optimize the hulls. I hope every new vessel, but it will show up when you are steaming how much drag you have in the hull. And it's much easier to design both one today than it was previously. You just have to experience to design the vessel. Yeah.
In my group, there are two engineers for this for vessel issues. I'm not in this sector. I'm more fishing gear technologies. But we were discussing together about this, and going directly to the fact that is a propeller is a pure speculation, but is a combination of factors. The most evident is that, and is also the well-known actually factor. So actually, in this working group, I now when I read the title of the working group, and with this I end my presentation, I understood why I'm here, because it's just for a simple for and not of. New technology for the Nordic fishing fleet, not new technology of the Nordic fishing fleet. So maybe I'm here to show possible transfer of technology and the way around. Thank you.